For proof, remember the formatting. You write out the question, you draw a line at the equal sign, and then you go through your strategies. So if you looked at this one and said, okay, I'm going to use strategy number 1, change everything to sine and cosine. Oh my goodness, it's already sine and cosine. Okay? Part of strategy 1 is I want to write both sides as a single fraction. Oh my goodness, it's already a single fraction on both sides. And so strategy 1 you can't even do because it's already done. And you're like, I got really good at strategy 1 and that's the only strategy I use, you're in trouble. Because there's nothing you can do at this point. So strategy 2, you start looking for your identities. Sine squared theta plus cos squared theta equals 1. And the 3 Pythagorean identities all have squareds in them. If you have a squared in it, you can use them. None of these are squared. So just because 1 minus cos squared theta is sine squared theta, we can't change 1 minus cos theta to sine theta. That's not allowed. So the Pythagorean identities only can be used if there's something squared. Okay? So if we think about our strategies, and I'll just point them as I'm referring to them, I'll just point them up here. Right? We couldn't use strategy number 1 in green. Strategy number 2 we can't use because there is no squareds for the Pythagorean identities. But we're going to be introduced to strategy number 3, which I sometimes call build the other side. And this is what it looks like. Now the reason I call it build the other side is because sometimes if you change to sine and cosine and you get a single fraction on both sides, like this situation, and things aren't the same, the build the other side strategy is saying, I know I can multiply by 1 on both sides, that's allowed. I know I'm not allowed to move things over from one side to the other because we draw the line. But maybe if I get something the same, maybe that will help me. And so the build the other side strategy says, decide to make something the same. Maybe you make your denominators the same. Maybe you make your numerators the same. So what I'm going to do here is I'm going to say, I want to make my denominators the same. This denominator is a 1 plus cos theta. This denominator is a sine theta. If I want them to be the same, this one would need to be multiplied by sine theta and sine theta. And this one would need to be multiplied by 1 plus cos theta and 1 plus cos theta. What that will do is at least, and I'm not even going to multiply out the bottom. I'm going to just leave it factored. At least my denominators are the same. So the build the other side strategy says if you have a fraction equal to a fraction, you've done all the other strategies, and they're not the same, make something the same. And in this case, I'm making my denominators the same. Now what's cool is that introduces sine squared on the top here, and on the top over here, 1 plus cos theta, 1 minus cos theta, that's a factored difference of squares. You can distribute everything, but because it's a difference of squares, you can right away go to 1 minus cos squared theta. So now, the reason that on the list that I wrote out, that you wrote out the other day, I had difference of squares mentioned, I had the word conjugate mentioned, is because all of your Pythagorean identities can be rearranged to make differences of squares. And when I multiply 1 minus cos theta by 1 plus cos theta, this 1 plus cos theta, these with the sign different in the middle, those are called conjugates. And I don't know if you remember that from grade 11 or not. It's not probably something you say every day and talk about in your math. So because you don't say that very often, you don't think of that word very often, to call a strategy by a word you don't use very often makes it harder to remember. Right? So multiplying by the conjugate is sometimes what this strategy is called. I renamed it build the other side. Sort of like, if I'm stuck, maybe I get something the same. And when you get something the same, this conjugate idea comes through. And now I have 1 minus cos squared theta. What can I do with that? That's one mental math manipulation of our Pythagorean identity, right? I can take sine squared plus cos squared equals 1. And with one little mental math thing, say, I can move the cos squared theta to the right. And I would get 1 minus cos squared theta. So I'm allowed to just immediately change that to sine squared theta. And our proof is done. How do you recognize that maybe you should use this strategy? Because sometimes this strategy is like a super shortcut, and sometimes it's not helpful at all. Okay? So, to build the other side, the difference of squares and the conjugate strategy happens when you get something like this, and when you look, like if this was an equation, you know that you could multiply across like this? Have you ever heard of cross multiplying? Basically what it means is that you first multiply both sides by sine, which would get rid of the sign on the bottom and move it to the top over here, right? And then you would multiply both sides by 1 plus cos. And it would remove it on the bottom and move it up over here. And if I cross multiply, do you see that I would get exactly what's on the top here? I would get my sine squared, and I would get my 1 minus cos squared theta. And that's my identity. So if you can see in the cross multiplication one of your Pythagorean identities, the build the other side strategy will probably solve it very, very quickly. Okay? But you're not allowed to do that in a proof, right? In a proof, you draw the line, nothing, you cannot move anything from the left side to the right side. Because you can do that if you have an equation that's equal to each other, but you're proving something. You don't know it's equal to each other yet. So we can only work on one side at a time. So this comes up a lot, the difference of squares idea, the conjugate idea. They love to use that in proofs. All right, and go to part B. Again, draw my line. Okay. Now in this proof, first of all, the red star on our strategy list was be aware of the other side. So before I just jump into strategy number 1 and do it, I look at both sides and decide, is there something I want to do instead? Like I see the cosecant squared theta, and I'm like, okay, that's one of my Pythagorean identities. Should I change it to cotangent squared theta plus 1? Maybe. But I look at this side, and I don't see any cotangent on this side. So for me, this one is still strategy number 1. I want to change things to sine and cosine. So careful here. Cosecant squared is 1 over sine squared. That 2 is in front. I left it out in front. It's really 2 over 1. A lot of students, because they know that cosecant theta is 1 over sine theta, they're very tempted when they write the sine squared theta on the bottom to move the 2 to the denominator as well. But if we do it step by step and slowly, we see that that 2 stays out in front, and if I multiply fractions, that would be on the top. So that is my right side changed to sine squared and written as a single fraction. My left side is not a single fraction. So how do I put two fractions together? You add fractions by getting a common denominator. So here, I'm going to need to, this one is missing the 1 plus cos theta. So I multiply top and bottom by 1 plus cos theta. And this one is missing the 1 minus cos theta. When I do that, I am going to get a common denominator. It's a difference of squares of 1 minus cos squared theta. On the top, I'm going to get 1 plus cos theta plus 1 minus cos theta. Can I simplify anything? Yes. Can you see that the plus cos theta and the minus cos theta will go away? And on the top I would just have 1 plus 1, which is 2. And on the bottom I have 1 minus cos squared theta, which is a squared. You should think of your Pythagorean identities, and sure enough, that's equal to sine squared theta. And now they're the same, so I can write my statement that the left side is equal to the right side. And we're all done. Right, you can circle question 12A.